We're going to continue doing problems of alkene nomenclature, and here's our strategy. Remember, we need to identify the parent chain, the longest that contains the functional group. Then we need to identify substituents and name them. This is numbering the chain to see where the substituents are, and list alphabetically. Finally, if there's any stereochemistry element here, we need to specify whether we have an alkene E or C, and if there are chiral centers, we need to assign the absolute configuration. So let's go for one structure here. That. Okay, so first step is, again, identify the parent chain, the longest that contains the functional group, that is my alkene. So I need to also, when I number the alkene, I have to number consecutively, 1, 2, say, the numbers for, say, the 2 vinylic positions. So here, if the chain starts here, I do 1, 2, 3, 4, 5, and 6. Right, so I cannot, for example, do 1, 2, not like that. I need to have the 2, say, consecutive numbers in the double bond, the vinylic position. Okay, if we see that 6 carbons, so what is our parent name? So we say hex, right? And then is 1 hexene, or we can say hex 1-ene, or if we don't say anything, it is understood that is in carbon 1, hexene. Okay, so now we need to see if we have substituents to the parent chain, and we do. So in carbon 2, I have a metal. In carbon 5, I have a metal. Since we have 2 metal groups, we're going to say dimetal. And now we need to write where they are. And so they are in carbons 2 and 5. So we're going to say 2, 5, dimethyl, 1 hexene. And again, remember that we can use that too. Now let's find out if we have any stereochemistry elements. And in this case, notice that I'm going to draw it in a different color. On carbon 1, we have 2 H's. So we don't have E or C stereo isomers. Since we have 2 substituents the same in one of the 2 vinylic carbons. So the name is complete as this. So let's do one more exercise with that. This time, I'm going to use a cyclic alkene. Let's see. One example that I have here. Okay, let's make it one easy at the beginning. Here we have a following alkene. Yes, so it's a 6-member ring. So first, what do? Identify the parent chain. So it is a cyclohexene. So I'm going to write that down. Cyclohex for 6 carbon, hexene. Yes, and now I have, when you are, next step will be identifying substituents, and we do have 2 metal groups. We need to number the chain now. And I want you to remember that we need to assign consecutive numbers to the 2 vinylic carbons. So I cannot say, it would be wrong if I say 1, 2, 3, 4, 5, 6. I need to say 1, 2. So, or it will be exactly the same if I say 1, 2. So 1, 2, 3, 4, 5, and 6. Again, remember that you need to do that, those 2 numbers consecutive for when you are doing the double bond. Next, what do we need to say? We have 2 metal groups. So it will be dimethyl. And now we need to say where they are. And they are in 1 and 2. So I'm going to say 1, 2, dimethyl cyclohexene. Now, I'm going to change one of those constituents, so this was the answer for that. But now I am going to just add one more carbon, and therefore, because I'm changing the constituent, I'm going to erase that. So now I have that. I know it's no longer dimethyl. I have one methyl group and another group. That group is different, and that is ethyl. And so we need to pay attention that once I have identified the substituents, I need to list alphabetically. So I have to say, and I'm going to change the numbering. Well, no. Yeah, we're good. So number one, again, their consecutive number, listing alphabetically, I need to say ethyl before methyl. So I'm going to say 1 ethyl, 2 methyl, cyclohexene. Yes? Okay, so we're going to do more exercises on that.